keep solving our physics GR exam. So 16 said that unpolarized lights on incident pair of in the ideal polarizer whose transmission axis make an angle 45 degrees with each other. The transmitted light intensities to both polarized. So basically, you need to know. Basically, you have unpolarized and go to some linear polarization mirror. So after that, so after this polarizer, the lights will have the same polarization. So the intensity is the half of the original, and then this is the another polarizer, which has the angle. If basically if this polarization if original polarization is T, then this is T, and if there's a direct angle between them, then there's a formula called the Mailers formula that if this is I prime, then I double prime will equals to I prime times cosine square. Okay, so this is the key point. So the intensity is basically original times cosine square, and cosine square in here is 45 degree. So it's half times I naught times 2/4. So it's 1/4 I naught. So it's 25%, 16. Okay, so 17. Basically, you have a very long straight wires carry a uniform density per unit length, and the electric field. Okay, so this is the standard Gauss service. You take this is R. So this region is 2 pi R the H times E is equal to 2 pi R H is equal to H lambda, right? Over epsilon naught. So basically, this is the Gauss law. This is dA. So it tells you that electric field is this one. E is equal to lambda divided 2 pi epsilon naught R. So the answer is A. The answer is A. The A. Okay, 16. So 18. 18 is just the length rule. Basically, okay. So let me quickly draw a figure. Okay, so if you have some NS, oh sorry. Okay, and you have the NS, and this is I should draw it into a straight line. This is A, this is B. Okay, and ask about so length rule means that the loop will start to construct try to prevent the magnetic field flows in. So now, and if NS is here, if one flows in, then you will first start him. So there will be NS, virtual MS start here. Then you will generate the current. So you can use your right hand rules to you can use your right hand rules to say you will find that there will be a current. So once, okay, so let me, because I think it's hard to, okay, so basically there are two properties in the, okay, so let me draw a graph to illustrate. So suppose the NS is come here, then there will be virtual NS happen. So if you have current, in order to generate N, then you will have this current on this side to generate N. So in this case, when S is coming in, you will have virtual S to block him. Then you can use your right hand rules. So you will have the current comes here to generate N. Okay, and when the magnet want to leave, suppose it's here, then it will start another S to get here. So when magnet want to leave, then the current will change the direction. So we should choose E. In the beginning is B from A, and another case is A from B. Okay, so 19 said the surface of sun has a temperature close to 6,000 Kelvin, and its emit black body, and the maximum near 500 nanometer, and for another is 300K, and ask about however. Remember that this is Wheeler's law. Lambda max T is constant. So we have this is black body, the property of black body. 6,000 times 500 equal to something times 300. So this tell you that this is 1,000 nanometers. Not not 1,000. It's 10,000 nanometers. So 10,000 nanometers is close to 10 micron. So the answer is A. So 12 is that at present of time, the temperature of the universe is 3K, and what's in 12K? So 12K means the universe is much close. The object in the universe is much close to each other. Okay, and the one thing you need to know is that this temperature is basically the inverse of the cosmic scale. Okay, so we know that the origin now is 3K, and before 12K. So that means cosmic scale is 1/4. So basically it's 1/4. It's 1/4. So the answer is A. 21 said that for a diabatic process involving ideal gas, we have. Okay, so you need to remember that in a diabatic case, you have PV gamma is constant. Basically you need to remember this. Otherwise, that you cannot solve the question. And then you have PV proportional to T. So you can plug V equals to T over P. You can plug P equals to something T over V. And this tells you that TV gamma minus 1 is constant. Okay, since you know this, so the answer is C. Okay, 22. An electron has total energy 4 times of the rest energy. Okay, so total energy is what? So this is standard special relativity is gamma mc squared, right? So you say the gamma mc squared is 4 mc squared. So gamma is 4, you tell me that 1 over 1 v squared c squared is 4. So you have 16 equals to 1 minus v squared c squared. 16 minus 16 v squared equals c squared is 1. So v squared over c squared is 15 over 16. So v over c is square root of 15 over 4. Okay, so the momentum is there are multiple okay, we should use we can use this way. So the momentum, so the total square e squared is b squared c squared plus m squared c to the fourth. So basically we can solve the momentum just by the total, use this equation. So maybe we don't have to solve the v squared, because we know this is this is 4 times m squared mc squared. So we have 15. This is p squared c squared. So we have 15 m squared c to the fourth, and we can divide this c squared from both sides. So the answer is square root of 15. So we should I should directly solve it without solving the velocity. So the answer is C. The answer is C. I think it's enough for today's video, and I will keep solving subject GRE physics. And I hope you guys think this is helpful, and be sure to subscribe to my channel.